Number 10. Did they have superpowers? Ever look up at a medieval cathedral and wonder how the heck they built that thing? Without cranes, without computers. Without even basic calculators, same. Those massive stone structures seem to literally defy gravity, with their impossibly tall spires and massive stained glass windows that somehow don't collapse under their own weight. It's enough to make you think those medieval builders must have had some kind of superpower, or at least a time machine where they could borrow some modern engineering know-how. But here's the mind-blowing truth. Those medieval master builders were working with little more than rope, wood, and their own brilliant minds. No superpowers necessary. Just generations of knowledge passed down through tight-knit guilds of stonemasons and some seriously clever thinking about how to make rocks float in the air. These medieval geniuses figured out that the secret wasn't fighting against gravity, it was using gravity's own force as part of their design. They basically tricked gravity into helping them build. How sneaky is that? When you stand inside a cathedral like Notre Dame in Paris or Canterbury in England, looking up at those soaring ceilings that seem impossibly high, you're witnessing one of humanity's greatest architectural magic tricks. In the wildest part, many of these builders couldn't even read or write. They didn't have engineering degrees or fancy textbooks. What they had instead was practical experience, trial and error, sometimes catastrophic error, and an apprenticeship system that preserved and improved techniques over centuries. Number 9. Can rocks really fly? Have you ever seen a flying buttress? No, it's not a chicken part with superpowers. It's actually one of the medieval builders' most genius inventions, and it's the reason those massive cathedrals don't just collapse into a pile of very holy rubble. Picture this: you're trying to build the tallest, most impressive church anyone has ever seen. You want massive windows to let in colored light through stained glass because, hello, divine inspiration. But there's a teensy problem: the taller you go, the more your walls want to push outward and collapse. Not ideal for worshippers. Enter the flying buttress, arguably the medieval world's most important architectural innovation. These external stone arches quite literally push back against the walls of the cathedral, counteracting the outward force. They're like architectural bodyguards standing outside the building and keeping it from splitting apart. What's wild is how these buttresses transformed a structural necessity into something beautiful. If you look at Notre Dame in Paris from the outside, those curved stone arches don't just hold up the building, they create a rhythmic, almost dance-like quality around the exterior. Medieval builders were basically saying, oh, we need to stop this building from collapsing, let's make the solution gorgeous while we're at it. And the best part about these flying buttresses, they let architects go absolutely wild with windows. Before buttresses, walls needed to be thick and solid to support the roof's weight. With buttresses taking on that load, walls could be thinner and filled with enormous stained glass windows. That's why when you walk into a Gothic cathedral, you're bathed in this otherworldly colored light filtering through stories told in glass, all because some clever person figured out how to make stone arches do the heavy lifting. Number 8. Why don't those massive domes collapse? Imagine trying to build a dome that weighs thousands of tons without modern materials or machines. Sounds impossible, right? Yet medieval builders created massive domes that have stood for centuries. How did they pull off this architectural magic trick? The dome of Florence Cathedral, the Duomo, is a perfect example. Completed in 1436, it spans an astonishing 144 feet and weighs approximately 37,000 tons. Yet it stands there century after century without concrete, without steel reinforcement, without anything but brick and stone. What gives? The secret lies in something called a herringbone pattern. When Filippo Brunelleschi designed the Florence Duomo, he arranged some of the bricks in a zigzag pattern rather than in straight horizontal layers. This distributed the weight in a way that prevented the dome from spreading outward and collapsing. It's like how you might lace your fingers together to create a stronger grip. Those interlocking bricks create structural integrity through their arrangement, not just their individual strength. But that's not the only trick medieval builders had up their sleeves. Many domes actually contain hidden chains, literal metal chains embedded within the masonry that work like a belt, holding the structure together at its widest point where the outward pressure is greatest. St. Peter's Basilica in Rome has 6 massive iron chains hidden inside its dome. Think of it as the architectural equivalent of wearing a belt with your pants. It keeps everything from falling down in a very embarrassing structural failure. Perhaps most clever was the double shell approach. Many large cathedral domes aren't just a single layer, but 2 domes nested one inside the other. This creates a lighter structure while maintaining the appearance of a massive dome from both inside and outside. It's like wearing a puffy coat that looks substantial but is actually filled mostly with air. These medieval builders were masters of creating the illusion of solidity while actually using materials efficiently. Number 7 were medieval construction sites' death traps. What was the workplace safety record like when building 300-foot tall stone structures without hard hats, safety harnesses, or OSHA regulations? You might be surprised. While there were certainly accidents, sometimes catastrophic ones, medieval cathedral construction wasn't the death sentence you might imagine. Records from various cathedral building projects suggest that serious accidents were actually relatively rare considering the scale and danger of the work. For instance, during the approximately 200 years it took to build Cologne Cathedral, documents record only 2 worker deaths. Not per year total. Though record-keeping wasn't exactly meticulous, so take that with a grain of salt. That doesn't mean it wasn't dangerous work. Scaffolding was made of wood lashed together with rope. Builders would climb hundreds of feet in the air on wooden ladders. Heavy stones were lifted using human-powered treadwheel cranes, basically giant hamster wheels where workers would walk inside to power the lifting mechanism. One slip could send stones crashing down. But medieval builders developed surprisingly effective safety measures. Many cathedrals feature what historians call mason's staircases, spiral staircases built into the walls that allowed workers to move up and down safely without ladders. Some sites had primitive but effective safety nets made of rope to catch falling workers or materials. And the guild system that trained cathedral builders included strict protocols for safely managing these complex projects. The pace of construction also helped with safety. Unlike today's rushed building schedules, medieval cathedrals were multi-generational projects. Cologne Cathedral took 632 years from start to finish. Notre Dame in Paris took about 182 years. When you're not rushing, you can be more careful. Perhaps the most interesting safety feature was theological. Cathedral construction was considered holy work, and many projects began each day with prayers for safety. While this might not seem like an effective safety measure to modern minds, psychological research suggests that rituals that promote mindfulness and care actually do reduce accidents. Those morning prayers might have helped workers stay focused and careful throughout the day. Number 6, how did they lift those giant stones without engines? Ever tried moving your sofa up a flight of stairs? Now imagine moving a 1,000-pound stone block to the top of a 300-foot tower without electricity or hydraulics. Medieval builders did this daily, and their solutions were ingenious. The star of medieval construction was the treadwheel crane, essentially a giant wooden wheel with people walking inside it like hamsters to generate lifting power. These human-powered cranes could lift astonishingly heavy loads. The best surviving example is at Beauvais Cathedral in France, capable of lifting 8 tons when operated by multiple people. That's the weight of an elephant, lifted by people simply walking inside a wooden wheel. But how did they get materials to the top of these soaring structures? One word: scaffolding. But not like the metal scaffolding we see today. Medieval scaffolding was an art form in itself, built from timber and embedded directly into the walls as they rose. If you look closely at many old cathedrals, you can still see the putlog holes, square openings in the walls where horizontal scaffold beams were inserted. As the walls went up, so did the scaffolding, creating a wooden skeleton that surrounded the growing stone structure like a cocoon. For the truly high sections, builders sometimes constructed temporary wooden structures called false floors inside the cathedral. Workers would build a wooden platform at a certain height, complete the stonework to that level, then build another platform higher up, gradually working their way toward the heavens. The roof of Westminster Abbey still contains some of the original 13th century wooden formwork that was supposed to be temporary, but has now lasted over 750 years. Perhaps most impressive was the medieval block and tackle system. Using a series of pulleys and ropes, builders could multiply the force applied to lift heavy objects. A skilled operator could position a massive stone with surprising precision using just rope systems. Some master builders became famous specifically for their ability to design lifting systems, like William of Sens, who designed specialized machines to rebuild Canterbury Cathedral after a fire in 1174. Number 5. Why don't those skinny stone columns buckle? Have you seen those impossibly slender stone columns in Gothic cathedrals? They look like they should snap under all that weight, right? Yet some have been standing for 800 plus years without even a wobble. What gives? The secret is in something called bundled columns. What looks like a single skinny column is often actually a cluster of smaller columns grouped together. Think of it like a bunch of skinny people huddling together. They create more stability as a group than any one person could provide alone. These bundled columns distribute weight more effectively while maintaining an elegant, soaring appearance. Another brilliant trick was the use of different stone types in strategic locations. Medieval builders didn't just grab whatever rocks were lying around. They carefully selected specific stones for specific purposes. For columns that needed to bear massive weight, they chose the densest, strongest stone available, often transporting it from hundreds of miles away at enormous expense. The cathedral at Chartres, for instance, features columns made of stone from quarries over 100 miles distant, chosen specifically for its compressive strength. But perhaps the most ingenious feature of Gothic columns is how they transform from round to square shapes as they rise. If you look closely at Gothic columns, you'll notice that many begin as round columns at floor level but transition to square shapes where they meet the ceiling vaults. This isn't just decorative, it's a brilliant engineering solution that helps distribute the load from the angular ceiling vaults down through the rounded columns. Of course, not every medieval builder got the engineering right. The ambitious cathedral at Beauvais in France suffered multiple collapses because its columns were too slender for the weight they needed to support. Its choir vault collapsed in 1284, and centuries later its crossing tower at 502 feet, the tallest in Europe, came crashing down in 1573. Medieval architecture was very much a process of trial and error, sometimes spectacular error. Number 4. Did medieval builders use secret mathematical codes? Did cathedral builders hide sacred geometry and mysterious mathematical ratios in their designs? The internet is full of theories about secret codes in medieval architecture, but what's the real story? While there weren't exactly Da Vinci Code-style secret societies, medieval builders absolutely used sophisticated geometry. They just weren't secretive about it. The sacred geometry was actually quite practical. Builders used geometric relationships that could be laid out with just a compass and straight edge, no complex math required. This was essential since most builders couldn't do written calculations or even read. The most common geometric tool was the ad quadratum technique, starting with a square and rotating it to create a dynamic series of proportional relationships. By drawing diagonals through squares, builders could find perfect proportional measurements without needing to calculate anything. A master builder could design an entire cathedral using just a rope with knots tied at regular intervals, a stick, and knowledge of these geometric relationships. Many cathedrals do incorporate the golden ratio, approximately 1:1.618, a proportion that appears throughout nature and creates visually pleasing relationships. But this wasn't because of mystical reasons. It was because these proportions were proven to create balanced, stable, and aesthetically pleasing buildings. Perhaps the closest thing to a secret code was the mason's mark. Each stonemason would carve a personal symbol onto the blocks they cut, a kind of signature used for quality control and payment purposes. Thousands of these marks still exist on cathedral stones, ranging from simple geometric shapes to more elaborate designs like animals or tools. Some cathedrals have documented over 500 different masons' marks, giving us a glimpse into the small army of craftspeople who built these massive structures. The real secret of cathedral design wasn't mystical at all. It was the way knowledge was transmitted through apprenticeship. Young masons would train for 7 to 10 years, learning techniques through direct observation and practice rather than written instructions. This practical knowledge was carefully guarded by guilds, not because it was mystical, but because it was literally their livelihood. The true code of cathedral builders was the accumulated wisdom of generations passed down through working alongside masters. Number 3, how did they keep everything from falling down mid-construction? Ever tried to build a house of cards? That tense moment when you're halfway through and everything could collapse. Now imagine that feeling lasting for decades while building a massive stone structure. How did medieval builders keep their cathedrals from collapsing before they were finished? The answer is wooden centerpieces called centering or formwork. These enormous wooden structures, essentially full-sized wooden models of the stone arches and vaults, held everything in place until the mortar dried and the stones could support themselves. Think of them as architectural training wheels. Creating these wooden frameworks was an art form in itself. Master carpenters would build elaborate wooden structures exactly matching the curves and angles of the planned stone arches. Stone pieces would be laid on top of this wooden framework, and only when the keystone was in place and everything was stable would the wooden support be removed. This removal process, called striking the centering, was a dramatic moment. Imagine the tension, all that stone, previously supported by wood, suddenly having to stand on its own. Many cathedrals have legends about this moment, including stories of master builders who would stand directly under the arch when the centering was removed to demonstrate their confidence in their work. Talk about putting your money where your mouth is. The most astonishing part. This wooden formwork was temporary, designed to be removed and often reused elsewhere in the building. Yet building it required almost as much skill as the stone structure itself. In some cases, the wooden centering was so complex that it required more engineering knowledge than the final stone product. All that genius carpentry, created just to be dismantled once the stones were in place. Sometimes the process went catastrophically wrong. In 1284, the newly completed choir vault of Beauvais Cathedral collapsed. The wooden centering had been removed too soon, before the mortar had fully cured. The entire structure came crashing down. Fortunately, it happened at night when no one was in the cathedral. Builders learned from this disaster, and when they rebuilt, they let the mortar cure for a full year before removing the wooden supports. Number 2, how did they design without computers? Imagine trying to plan a 500-foot-tall stone structure with no CAD software, no structural analysis programs, no calculators, not even graph paper. How did medieval architects design their massive cathedrals with such precision? They drew on the floor, literally. Many cathedrals had special rooms with large flat floors called tracing houses, where architects would draw full-size plans of structural elements directly on the floor. The tracing floor at York Minster in England can still be seen today, a massive room with a plaster floor where generations of master builders drew their designs at 1:1 scale. For smaller details and initial designs, medieval architects used wax tablets that could be erased and reused, medieval iPads, if you will. They also used parchment, though it was expensive, making preliminary sketches before committing to final designs. Some of these sketches survive, like the famous 13th century sketchbook of Villard de Honnecourt, which contains drawings of buildings, mechanical devices, and construction techniques. Perhaps most impressive were the scale models. For particularly complex structures like domes or tower spires, architects would create detailed wooden models. The Museo dell'Opera del Duomo in Florence still displays Brunelleschi's wooden model of the dome for Florence Cathedral, a masterpiece of miniature engineering that allowed workers to visualize the final structure and understand how to build it. The most mind-blowing aspect of medieval architectural design was how much was done through proportional systems rather than exact measurements. Rather than specifying "make this column 24 feet high," a medieval architect might specify "make this column 5 times as high as it is wide." This proportional thinking meant that designs could be scaled up or down as needed and adapted to local conditions without losing their structural integrity or aesthetic harmony. Mistakes still happened, of course. The south spire of Chartres Cathedral is noticeably different from the north spire because the original design was lost during the decades it took to build, and the later architects had to improvise. The west front of Lincoln Cathedral in England shows visible signs where builders realized the towers were beginning to lean and had to adjust their design mid-construction. These buildings were as much problem-solving exercises as they were artistic creations. Number 1, did they really take centuries to build? Would you start a project knowing you'd never live to see it finished? Medieval cathedral builders did exactly that. But why did these buildings take so long to complete, and how did construction continue across multiple generations? Cologne Cathedral holds the record for the longest construction time, 632 years, from 1248 to 1880. That's not a typo. The cathedral took over 6 centuries to complete. Notre Dame in Paris took 182 years. Canterbury Cathedral was under constant construction or renovation for 221 years. These weren't delays or inefficiencies. Multi-generational building was part of the plan. The primary reason for these extended timelines was funding. Cathedrals were monumentally expensive. The stone for Notre Dame had to be transported from quarries miles away, with each block moved by horse-drawn cart or boat. Skilled stonemasons commanded high wages. Stained glass was created with rare minerals for colors. No single generation could afford to build a cathedral outright, so construction proceeded as funds became available. Medieval cathedrals were also built in distinct phases that could be used while construction continued elsewhere. Builders typically started with the choir, the east end where the altar stands, so religious services could begin while the rest of the cathedral was still under construction. Many cathedrals functioned for decades or even centuries with temporary wooden roofs covering unfinished sections. This generational approach led to changing designs mid-construction. Gothic architecture itself evolved during the time many cathedrals were being built, leading to visible shifts in style from one end of a cathedral to the other. The west front of Wells Cathedral shows a clear progression from early English Gothic to decorated Gothic style as your eye moves upward, a three-dimensional timeline of architectural evolution. Perhaps most remarkable is how consistently these multi-generational projects stayed true to their original vision. Master masons would create templates of key design elements, wooden or metal patterns that preserved exact shapes and proportions. These templates were treated as treasures, carefully stored and passed down to ensure consistency decades or centuries later. The flying buttresses added to Notre Dame in the 13th century matched the 12th century design so perfectly that most visitors can't tell they weren't part of the original construction. The generational nature of cathedral building created a unique psychological effect too. Medieval builders were participating in something greater than themselves, a project connecting past, present, and future. Stonemasons would carve details in high places no human would ever see clearly, not for earthly recognition, but as offerings to God and contributions to a structure they knew would outlive them by centuries. Were they truly building for eternity? As the ongoing restoration of Notre Dame after the devastating 2019 fire reveals, even centuries-old stones eventually need care. The medieval builders would likely be astonished to know their work still stands today, or perhaps they wouldn't be surprised at all. After all, they built not just with stone and mortar, but with the understanding that they were creating something that would connect countless generations through a shared experience of wonder. When you look up at those soaring vaults and seemingly impossible stone structures, aren't you experiencing exactly what they intended?